हेलो फ्रेंड्स, आज हम जो है हैकरास के ट्यूटोरियल को आगे बढ़ाते हैं। और आज हम देखेंगे कि हम जो है क्या जो है प्रीवियस वीडियो में देख चुके हैं और हम क्या आगे जो है कि वर्कआउट करने जा रहे हैं हैकरास के अंदर। सो दिस इज़ हैकरास सॉफ्टवेयर विंडो। Here we have to open our project which we developed in previous videos. So I have saved that in my T drive with third folder trial, and the project name is trial. So I have opened this project. Here we can see that I have created this project, and I have set I have I have properly assigned a geometry to this project, and this is a 2D modeling I am doing here. So 2D area I have assigned. So how I have assigned this 2D area, and how I have assigned this unsteady flow to the model, and how plan is designed, and after that how I run this model. So all these things I'm going to explain here. So first of all, you have to click here like RAS mapper. So in RAS mapper you can see uh, here there is 2D area in geometry section. There is a 2D area. First of all, I'm checking this result. I will show it later. First of all, if you want to see the 2D area, so I have to check in and how I have created this 2D area. Like first of all, zoom to the layer. So here you can see that this is our distribution model which we have inserted to this model in previous videos. So how I did this, so let's create one more geometry here. So for that you have, suppose I'm going to delete it. So for to delete you have to go in edit mode, then you can delete it, or here there is option to delete the geometry. So let's click on this, and the geometry is deleted. Now here there is no geometry, and for to create this geometry you have to right click here, and you have to create new geometry. Then you can create a geometry, or you have a geometry which you saved previously, you can import that geometry here. And now you want to create new geometry, you have to click here to create new geometry. This is one way, and another way is like you have to cross it, and you have to go here. Here you can see your distribution model. For to create new geometry you have to click on this 2D flow area. So because I am going to do 2D flow modeling, so you have to click on 2D flow area. So when you click 2D flow area, you have to start from left bank. This is a thumb rule, you have to start from left bank. To do anything in this modeling process, you have to start from left bank. Like in life you have to do everything from right hand, but in modeling, in HEC-RAS modeling, you have to do from left bank. Model will understand the flow direction by this. So our flow direction from upward to downward. So from where I have started, this digitization is from upstream direction. So now I have to close this area, and we have to give a name like 2D area I have created. So this is 2D area, and if you zoom here at this place, you will see there is some miss uh, like some unevenness here. So to correct it, you have to go on edit, you have to move pointer object, you have to click on that. You will get this cursor, and you have to just click and move it from here to there. And after that you have to again click on that tab. It will again force to make a 2D area, and this is uh, just a 2D area. There is no grid, there is no cells. So to assign cell, to assign grids here, by which on which HEC-RAS equations will apply to uh, give you flood inundation, to give you the flood extent and flood depth, flood velocity, everything. So for that you have to bifurcate, or you have to like give grids to this area. So for that you have to left click here. You have to go edit to the flow area, and here by default Mannings is taken 0.06. You have to give accordingly, like what area you are covering, average what Mannings is there. To assign Mannings to each cell, there is option, you have to do that. There is edit land cover to Manning, so you have to check your land cover. On that basis you have to give roughness coefficient to the, and after that you have to assign those Mannings to each cell. That will give a more realistic view. But for trial and for this tutorial purpose, I am giving here 0.03 Mannings all over the area. This is the default Manning. And next you have to click here to give the cell size, which like in the demo which I have uploaded here, the cell size or the resolution is 5 meter by 5 meter. But the catch is here, like if you take less spacing, less cell size, it will take more time in computation. So this is a trial video, so I am taking 50 by 50 grid size, by which I can run it quickly and show you the results and everything. So uh, you have to click here to generate the point. After that you can force necessary computation, it will create the mesh. So here you can see that approx 17784 cells have been created, and average cell size is approx 2.5 meter square. Now this, you can see the cells here. And after that you have to assign boundary conditions as well, because we have to give the flow and everything. So for that you have to assign boundary condition. So for boundary condition you have to zoom at upstream first of all, and you have to click on boundary condition. After that you can start uh, full plot, and after that you have to click on boundary condition. And okay, you have to click on boundary condition. You have to start from left to right, and you have to give upstream boundary condition. So right here upstream, and for downstream boundary condition you have to, again click on boundary condition lines, and you have to start from left to right, and give the name downstream boundary condition. And after that you have to save this, save geometry, like geometry, and it will save in geometry.g format. And after that um, your geometry is created. Now you have to go in RAS mapper, where you can see your geometry. In geometry section you can click on geometry. You have to click on 2D area. This area I have created in geometry. You have to click on edit section. If anything you want to change, you can change here, or you have to stop editing. Your geometry is created properly. And one more thing you have to do, you have to compute the 2D flow area hydraulic table. So you have to do this, and after that you have to assign your flow, and then you can run your model. So 2D area is completed, and now you can save it in the RAS mapper. That is saved properly. Now you have to edit your flow, like here, and steady flow I have saved here. So like in downstream I'm going to give normal depth. So this river is Ghagra basin, so I have according to literature and everything, the normal depth or the slope, fictional slope is 0.0002 per kilometer I have seen. uh, and this one I have applied. But you can go with the literature and everything. You will get the average slope of the area. Generally Generally, the slope is approximately point triple four times zero. Like in 1 kilometer, the total area is 8 kilometer here. But if you go for some area point triple zero eight, so that's okay. That according to literature and everything, I have given point triple zero two, and you can check it by the terrain, by the river and or literatures. And in upstream, I'm going to give a like flow hydrograph. So I want to give it a monthly hydrograph from 1st January, and the time step is from 1200, so 1st January 2008 to. So suppose here I am taking a random flow data. So maximum flow came in approx, suppose in September. So I'm taking 5000 maximum, and minimum 500 in January, and in December you can take approx 1000. And let's interpolate the thing, and you can see this plot, this type of a random plot comes out. So I have taken this hydrograph, and we have to give easy slope to 0.0.01. So easy slope I have given to the model, and you have to save this flow. So this flow I am saving with an steady. So you can save it with another name, and steady one. I'm saving this, it's saved properly. Next and last step, we have to run your model. So to run the model, you have to assign the date and everything. And suppose I have taken 30-minute computational interval, and study one geometry is my geometry. There is two flow. I have second one which I saved is a study one. And after that you have to click on run. The model will run. In 30 minutes it is giving some iteration error. So if you reduce this computational interval, it will take less time. It will give less error, computational error. But for here, this is trial, so I have taken this 30 minutes, and the result you will see in a RAS mapper. In RAS mapper, for result like previously, I have run one model. So let's pause or stop it. It will take some time. So to show you the result, this type of result you will get, and this is during January. Here we can see that this is during January. For February, you have to click here. It will change the extent or change the depth. Change the depth. You can stop here. I have to mm, like you want to see how flow is passing from diverting from this stage to here and there. So for that you have to click uh, here. When you click here, it will show you the flow direction. So by this black arrows, you can see maximum flow is going this direction. Some part 30 to 40% flow is going in this direction, and speed, if you want to increase, you can see that this is animation by which you can see in January this much of flow is going this direction, this much flow is going in this direction. But in another months, you can increase it or drag it from here to another month. Other months you will see the inundation and its extent. Similarly, you can see the maximum flow direction and everything. Here you can see this the depth 3.797, and it is changing because here it is continuously changing the days. Like I have taken computational interval 1 month, 1 day, so it is hourly. So it is changing hourly to hourly, 5, 6, 7, 8 every day. Like 24 hour in a day, 24 hour is changing. It runs on hourly basis. So it is the result is changing every hour. Depth, velocity, everything is changing. As you see depth, you can see the velocity as well. Uh, Velocity you can see also here. To see the velocity, this is the velocity in first month, and similarly the velocity to see the depth and velocity is 0.61 this month, and when you drag this to another month, you will see the depth, velocity, everything here extent as well. So this is the general result uh, of HEC-RAS modeling, flood inundation modeling, and we will see something new or something good in next videos. Thank you to that.